All right, let's dive into something that sounds like it's straight out of science fiction, but is actually at the cutting edge of physics. What if the universe just built itself? We're going to explore this wild idea that the laws of physics aren't random at all, but maybe they're the only set of rules that could have ever existed.
And that brings us right to the heart of it, to this huge, almost paradoxical question. Can the universe actually define its own rulebook, from its own internal logic? It sounds totally circular, I know, but there's a revolutionary way of thinking in physics that suggests this might just be the deepest truth of all.
This quote nails it. Just imagine for a second. You don't need to give a theory a shopping list of particles or forces to get it started. No. Instead, you just begin with pure logical principles. And from those rules alone, the entire structure of reality, all the particles, all the forces, it just emerges. It's like the universe is the one and only solution to its own cosmic puzzle.
Okay, so let's get into our first section here, the physics paradox. We're going to see how this new way of thinking, which folks call the bootstrap method, completely flips the script on how we've been trying to build a universe from scratch for the better part of a century.
So for a long time, physics has worked kind of like this. You pick your fundamental ingredients, an electron, a photon, a quark, and then you write down a big equation, a Lagrangian, that basically describes how they all interact. It's a bottom-up approach. But the bootstrap method, it's the complete opposite. You start with no ingredients at all. You just begin with a few non-negotiable rules of logic, and then you ask the big question, what kind of universe is even possible if it has to follow these rules?
So let's dig into what those rules actually are. Section 2, the universe's logic rules. And I absolutely love this subtitle, the cosmic Sudoku, because it is the perfect analogy. When you're doing a Sudoku puzzle, you don't just invent numbers and stick them in the grid. No, you deduce where they must go based on the rules. Well, the bootstrap idea suggests our entire universe works just like that.
And these rules aren't some kind of exotic, super complex thing. They're actually principles that any sensible, functioning reality would have to obey. They're the absolute foundation of consistency. So what are they?
First up, we've got something called unitarity. Really, this is just cosmic common sense. It means if something happens, the chances of all the possible outcomes have to add up to exactly 100%. A particle can't have a 50% chance of going left and a 60% chance of going right. The math has to work. Something has to happen.
The second big rule is called crossing symmetry, and this one is all about perspective. It basically says that the fundamental math that governs how particles interact has to be the same whether you're looking at a particle coming into a collision or leaving one. The laws of the universe don't just change because you're looking at the event, forwards versus backwards.
So this three-step process is really the engine behind the bootstrap. You start with just those basic rules, those symmetries. Then you insist that any theory you can dream up must obey them, no exceptions. And what's amazing is that when you enforce that strict logical consistency, you find that your options become incredibly limited. And often, only one or maybe a few theories with very specific particles and forces pop out as the only possible solutions.
Now, I know what you're thinking. This all sounds very abstract, right? But did it actually work on a real problem? Let's get into Section 3, cracking a concrete case. We're going to look at some stunning proof for this idea, and it was found not out in the cosmos, but inside a simple magnet.
So, physicists decided to test this whole bootstrap method on a really famous problem in physics called the Ising model. It's a classic textbook model that describes how all the tiny atomic spins in a material, like iron, decide to line up and point in the same direction, which is what creates a magnetic field. It was the perfect little laboratory to test out these big ideas.
The big challenge was to calculate something called critical exponents. Now, these are these hyper-precise numbers that act like a unique fingerprint for the system, and they define its behavior right at that critical moment, the exact temperature where it becomes magnetic. And let me tell you, calculating these things the traditional way is notoriously difficult.
And this is where the bootstrap just showed its incredible power. Using only the rules of consistency, unitarity, symmetry, and a few others, physicists were able to calculate this number to an absolutely astonishing degree of precision. And here's the kicker. They didn't plug in any information about atoms or forces. They just solved the cosmic Sudoku for the magnet, and this number just emerged. It was part of the one and only solution. So, if the bootstrap can crack a really tough problem like that, it immediately begs the question, what's the biggest, most fundamental puzzle we could possibly throw at it?
And that brings us to section 4, deriving gravity from logic. This is the ultimate puzzle. Could we bootstrap the fabric of space-time itself?
Now, to even try to tackle this, physicists use this amazing theoretical tool called the ADS/CFT correspondence. You can think of it like a hologram. It's this deep mathematical dictionary that connects a complex universe with gravity inside some volume to a much simpler universe without gravity that lives just on the surface or the boundary of that volume. So you can solve problems in the simple world on the boundary to learn about the complex world with gravity inside.
And this is the huge payoff. By applying those bootstrap rules of consistency to that simpler theory on the boundary, physicists are discovering that gravity inside the volume isn't just an option, it's a requirement. The existence of gravity becomes an inevitable, logical consequence of the system. You don't have to add it in, it has to be there for the whole thing to make any logical sense.
So, all of this leads us to our final, grand revelation. Let's head into our last section. Is reality self-defining? It's time to put all of these pieces together and really think about what this means for everything.
And here's the core implication, the big mind-bending idea. If fundamental parts of our universe, things like particles and even gravity itself, can be derived from just a handful of logical rules, well, then those laws might not be arbitrary at all. Maybe we didn't just get lucky and end up with this particular set of laws. Maybe no other set was ever even possible.
There's actually a technical name for this idea. It's called a unique fixed point. And it's the concept that our universe is the single, stable, inevitable solution that just naturally arises when you demand that reality has to make sense. Just like the solution to that Sudoku puzzle, it might be the only answer that satisfies all the rules.
And what's so fascinating to me is how this idea doesn't just live in a physics bubble. It bridges all these different fields. In physics, it's at the heart of things called conformal field theories. In pure mathematics, it connects to how abstract symmetries work. And even in philosophy, it echoes the mind-bending work of Kurt Gödel on self-referential systems, systems that can describe themselves. It really points to some deep, underlying unity in the structure of logic itself.
So here it is, the ultimate takeaway. The universe might not have needed a blueprint. It might not have needed a set of finely tuned dials or a list of ingredients at the very beginning. It could have just sprung into existence for one simple reason, because it was the one and only way for a complex reality to exist without contradicting itself.
Which leaves us with one final, and I think really profound question to chew on. If our universe, and by extension you and me, if we are all just part of a unique solution that was determined by nothing more than pure logic, what does that say about that age-old question of why we're here? The answer might be the simplest and maybe the most stunning of all. Because in a logical reality, we couldn't have been anywhere else.